Assalamualaikum and a very good day. Today we are going to have a look at the chapter series. In this chapter, there will be three main subtopics. The first one is the binomial expansion. Second one is the arithmetic progression. And the third one is the geometric progression. Take note that the binomial expansion subtopic will be asked in the GCSE examination. But for arithmetic progression and geometric progression, will be asked in both SPM and GCSE. So for today's video, I will talk about the first subtopic, which is the binomial expansion. Alright, before we go straight to the binomial expansion or binomial theorem, let's first discuss what does it mean by binomial terms. Okay, binomial terms are polynomials with two terms. For example, A plus B is a binomial term. Or maybe 2x plus 3y is also a binomial term. Or maybe 3 plus 2x, also a binomial terms. Basically, binomial terms consist of two terms, the first term and the second term. First term, second term, first term, and second term. Whenever you have a polynomial involving two terms, this is known as the binomial term. Okay, I want to talk about the expansion of a binomial term. For example, if you have A plus B squared, most of the students will understand that to expand it, it will become A squared plus B squared. Or maybe if we have A plus B to the power of 3, some student, they will assume that he or she will assume that this is just equals to A to the power of 3 plus B to the power of 3, which is for both is false. Why? Let's have a look. Why? Say we have A plus B squared. Say we substitute as 2 plus 3 squared. So equals to 2 squared plus 3 squared, which is just equals to 4 plus 9, which is just equals to 13. This is directly by using that assumption. But the truth is, 2 plus 3 squared is just equals to 2 plus 6 is equals to 5 squared, which is just equals to 25. So which one is true? Obviously, this one is false. So whenever you have A plus B squared, this is not equals to A squared plus B squared. What you need to do instead, you need to expand it individually. Means that, for example, say we have A plus B squared. Okay. So A plus B squared is just equals to A plus B multiply with A plus B. So expand this manually, you should get A times A plus B with A plus B. Just do the normal expansion. You will get A squared plus AB plus B squared. Plus this is AB plus with B squared, which is just equals to A squared plus 2AB plus with B squared. Okay, so you cannot assume this. This is wrong, definitely wrong. Need to expand one by one. Similarly to this example here. We are having A plus B to the power of 3. If you want to expand it this way, this is definitely wrong. What you need to do, you need to expand manually, which is equals to A plus B times with A plus B times with A plus B, which is just equals to A plus B multiply with, from here, we know the result is this. Okay, which is just equals to A squared plus 2AB plus B squared. Expand manually, A squared plus 2AB plus B squared plus with B times with A squared plus 2AB plus B squared. So equals to A to the power of 3 plus 2A squared B plus AB squared plus A squared B plus 2AB squared plus B to the power of 3. So we will get final answer is A to the power of 3 plus with 2A squared B plus with so that's done, that one and that one, plus with 3AB squared plus with 3, that one, 3AB squared, 3 plus with B to the power of 3. So that is the answer, supposedly. But later we will learn on the faster way to expand binomial terms. Okay, so what I'm trying to say is that if you have A plus B to the power of n is not equals to A to the power of n plus B to the power of n. This is not true, because in examination I always came across students who did this. So this is just a reminder that using this concept is not true. So whenever you have A to the power plus B to the power of 5, say, we have A to the power of 5 plus B to the power of 5. This is definitely incorrect. Okay, wrong. You have to expand manually. A plus B, A 1 times, 2 times. You have to do it 5 times. Okay. Also, I want to recall on the definition of NCR. Okay. Also can be written as NR. So by definition, this means n factorial over r factorial times with n minus r factorial. You can directly find the answer for the value of NCR by using calculator, but it is very important for you to remember this formula, because you might need to use the concept when answering questions. So you are required to remember. Right. For example, if we have 4C2, which can be written also as 4,2. This is just equals to 4 factorial over 2 factorial multiplied with 4 minus 2 factorial. Okay, what does it mean by 4 factorial? We know that 4 factorial is just equals to 4 times 3 times 2 times 1. So if you look at 2 times 1, this is just equals to 4 times 3 times 2 factorial, basically. Because 2 factorial is just 2 times 1. So which means that 4 factorial, top here, is just equals to 4 times 3 times with 2 factorial over with 2 factorial times with 2 factorial. Okay, we can cancel out that and that. So 4 times 3 is just equals to 12 divided by 2 factorial is just 2 times 1, which is equals to 12 over 2. So the answers should be 6. But if you have calculator, you can just press NC for C2, you will get the answer. But again, I say that you need to remember, you need to know the definition of NCR, because you will need to use this definition in order to answer questions. And NCR is a part of the binomial theorem, which is basically the theorem that we need to expand a binomial terms. Suppose we have a plus b squared. So this is just equals to a squared plus 2ab plus b squared. Or it is just equals to a plus b multiplied with a plus b. So expand this, you will get a squared plus 2ab plus b squared. So easy expansion. What if we have, say, a plus b to the power of 10? So which means that we need to expand a plus b multiplied with a plus b multiplied with a plus b multiplied with a plus b. How many times? 10 times. Or maybe if we have a plus b to the power of 100, say. So which means that this is just equals to a plus b times with a plus b times with a plus b. How many times? 100 times. So if we expand manually, this binomial expansion is going to take us the whole exam time to just expand this. Not to worry. We have formula in order to expand this easily. So you do not have to do it manually, because if you do it manually, it's going to take the whole exam time, probably your whole life. Okay, so we have this formula in order to expand this. The formula is known as binomial theorem. So after this, we are going to look at what does binomial theorem says. Now we are going to have a look at binomial theorem. Binomial theorem states that if we want to expand a binomial, say a plus b to the power of n, this is just equals to start with nc0, a to the power of n minus 0, b to the power of 0, plus with nc1, a to the power of n minus 1, b to the power of 1, plus with nc2, a to the power of a to the power of n minus 2, b to the power of 2, plus with, you can sort of see a pattern, and the pattern goes on until the last term, which is just ncn, a to the power of n minus n, b to the power of n. Alright, if we have a look at the first term here, okay, actually anything we have nc0 will always equals to 1. Okay, so anything C0 will always equal to 1. For example, if you have 5C0, say, you press your calculator, you will get 1. Or 4C0 will always get 1. So it is known that this is just equals to 1. And anything to the power of 0 is just also equals to 1. So basically, the first term turns out to be a to the 1 times with a to the power of n minus 0 times with 1. And n minus 0 is just equals to n. So basically, the first term turns out to be a to the power of n. Okay. Now have a look at the last term. Again, the same concept. N C n will always equals to 1. Press your calculator. Say we take 3C3 as an example. You will get 1. Right? So means that this will equals to 1. And then a to the power of n minus n will equals to a to the power of 0 and b to the power of n. So which means that the last term will become b to the power of n. And the middle term is always the same. So we have the first term a to the power of n. So the next one should be n1 a to the power of n minus 1 b to the power of 1 plus n2 a to the power of n minus 2 b to the power of 2 plus with the pattern goes on until you see the last term. So this is the binomial theorem. Okay, so let me highlight that. So we have a plus b to the power of n equals to a. So this whole thing is the binomial theorem. Not to worry, because in your exam, this formula will be given. Now let's have a look at one example. Say we have, let me use other color, black. Say we have example, expand 2x plus 3 to the power of 3. Okay. 2x plus 3 to the power of 3. This is just equals to, by binomial theorem here, this is just equals to the first term, 2x to the power of 3 plus with 3, 1, 2x to the power of 3 minus 1, 3 to the power of 1, plus with 3, 2, 2x to the power of 3 minus 2, times with 3 to the power of 2, plus with, we have the last term which is just 3, 2x to the power of 3 minus 3, 3 to the power of 3. Okay. Since the first term is 2x, therefore you have to put 2x in bracket. Okay. Sometimes students like to do 2x to the power of 3. We need to know that the whole first term, a, is equals to 2x. So you need to put the bracket. It is a common mistake always made by student. Because when you expand this becomes 2 to the power of 3 x to the power of 3 plus with, okay, the next one, calculate 3c1 is just equals to 3 times with 2x to the power of 3 minus 1 is 2, then times with just 3 plus with 3c2, which is 3 also. Then 2x to the power of 3 minus 2 is just 1. 3 to the power of 2 is just here. 3 to the power of 2 is just 9. Plus with 3c3. We know that this is the last term. The last term is just equals to b to the power of n, which is this will produce 1. This will produce 1. It's just 3 to the power of 3. So 3 to the power of 3 is equals to 27. Now we simplify everything. Becomes 8x to the power of 3 plus with 3 times 3, 9 times with 4x squared. So when we expand that, it becomes 2 to the power of 2, x to the power of 2 plus with 3 times 2, 6, 6 times 9, 54. So the coefficient becomes 54, x to the power of 1 plus with 27. So is there any like terms? No like terms. So rewrite that back. Becomes 8x to the power of 3 plus 9 times 4 is 36 x squared plus 54x plus 27. Now let's have a look at one more example. Say that we have half x plus 3 to the power of 3. Expand this. For me, I always start with the basic formula, which is 3, 0. The first term is just 1 over 2x, and we know that 1 over 2x just equals to x over 2. Okay, so the first term should be x over 2 to the power of 3 minus 0, 3 to the power of 0 plus with 3c1. Let me use bracket to differentiate from the other symbol. So x over 2 to the power of 3 minus 1, 3 to the power of 1 plus with 3 to x over 2 to the power of 3 minus 2, 3 to the power of 2 plus with the last term 3, 3. Okay, let me shrink this a bit so we are going to have some space. So 3, 3, x over 2 to the power of 3 minus 3, and then 3 to the power of 3. Okay, simplify things. So this is just equals to, this is equals to 1, and that one also equals to 1. So we will have x over 2 to the power of 3 plus with 3c1 is just 3. Then we have x over 2 to the power of 2 times with 3 plus with 3c2 is just equals to, I think it's 6. Oh no, it's just 3. X over 2 to the power of 1. So we have done with that one done, that one done. Now we add the third term, which is so we have 3 to the power of 2 is just 9, multiply with 9. So done with the third term. The last term, 3c3 is just equals to 1 times with x over 2 3 to the power of 3 minus 3 is equals to 0. 3 to the power of 3 is equals to 27. So simplify things. We will get x to the power of 3 over, remember, indices properties. When you expand top and also expand bottom. So we get 2 to the power of 3 plus with 3 times 3 is 9 times with x to the power of 2 over 2 to the power of 2 plus with 3 times 9 is equals to 27. So x over 2 plus with anything to the power of 0 is always equals to 1. So plus with 27. So x to the power of 3 over 8 plus with 9 over 9x squared over 4 plus with 27x over 2 plus with 27. So I like to rearrange so that the coefficient of x to the power of something will be on the left hand side. So it becomes here 1 over 8 x to the power of 3 plus 9 over 4 x to the power of 2 plus 27 over 2 x plus 27. Okay. Next, we are going to talk about the anthem of a binomial expansion. Before that, just take note that we know that NR is just equals to NCR. Okay, this is from our prior knowledge. So the anthem of a binomial expansion, Tn, is just equals to TR plus 1, which is just equals to NR, A to the power of N minus R, B to the power of R. For example, find the third term of the expansion of 2 plus y to the power of 5. There are two ways to answer this question. The method 1 is that we expand this by using the binomial theorem. So we should have 2 plus y to the power of 5 is just equals to 5, 0, 2 to the power of 5 minus 0, y to the power of 5, plus with 5, 1, 2 to the power of 5 minus 1, y to the power of 1, plus with 5, 2, 2 to the power of 5 minus 2, y to the power of 2, plus so on. So since the question wants us to find the third term, therefore we only need to find the third term, which is this one. Okay. Because we know that this is the first term, this is the second term, and obviously this is the third term. You don't have to expand because you can stop at the third term. But somehow this method is going to take a longer time. For example, if they ask you to find the 10th term, it's going to be a problem since you need to expand until 10 terms and then only you take the 10 terms. So what alternative that we have is we use this formula here. Okay, the formula here. So basically, if we want to find the nth term, which in this case is the third term, we want to find T3. T3 is just equals to T2 plus 1. Okay, by the formula, so our r is equals to 2. This is our r. Okay, plus 1. Plus 1 is always there. Plus 1 is always in the formula. So our r is 2. So this is just equals to, by the formula, our n is 5. 5, 2. A is 2. 2 to the power of 5 minus 2. Y to the power of 2. Which is basically is the same. Okay. Now we simplify. We should get 5c2 equals to 10 times with 2 to the power of 3 y squared. So press your calculator. Should get 80 y squared. Here is T3 is also 80 y squared. So I would prefer for you to use directly the formula, method 2. And we can just erase method 1 and have a look at method 2. Okay. So find the answer is 80 y squared. One more example. Say find the 7th term of the expansion, maybe 2x plus 3 to the power of 10. So by formula of Tn, we know that formula. By formula, Tn is equals to Tr plus 1, which is equals to n r a to the power of n minus r, b to the power of r. So in this case, we have a plus b to the power of n. So we want to find the 7th term. So in this case, T7 is equals to T, obviously r is going to be 6, plus with 1 equals to, our n is equals to 10. 10, r is 6, our a is equals to 2x to the power of 10 minus 6, b is 3 to the power of 6. Okay, so which is just equals to 6 to 110 multiply with 2x to the power of 4 times with 3 to the power of 6 is equals to 729. Okay, so 110 multiply with 729, we should get 153090, and then 2 to the power of 4 is equals to 8, and we have x to the power of 4, sorry 16, so 153090 times with 16, and we have x to the power of 4. The final answer should be 2449440 x to the power of 4. Now I want to introduce the term independent of x. What does it mean by the term independent of x? So term independent of x means that there's no x in the term. So if we look at the previous example, here notice that in this expression, 27 is the term independent of x. Because it doesn't have any x, so it's the first, second term, fourth term, the last term, fourth term. T4 is the term independent of x. So for this expansion, the term independent of x is the same, the last term. This is term independent of x. And it's the 1, 2, 3, the fourth term again. Just take note that not all last term is independent of x, because there can be terms in the middle of the expansion can also be independent of x. And take note that it doesn't have to be x all the time. It can be independent of y, independent of s, independent of t. It depends on the variable used in the question. Now let us have a look at the example from past year questions. So we have write down in exadecimal power, means that from lower power to the higher power of the first four terms in the expansion of 2 plus x squared to the power of 6. And we know that binomial theorem states that if we have a plus b to the power of n, this is just equals to n0 e to the power of n minus 0, b to the power of 0 plus with n1, e to the power of a to the power of n minus 1, b to the power of 1, and it goes on until nn, a to the power of n minus n, and b to the power of n. And we know that the first term is just equals to a to the power of n, and the last term is just equals to b to the power of n. So basically, now we want to expand 2 plus x squared to the power of 6. This is just equals to the first term is just an, so our a is 2, so our n is 6, so it's just 2 to the power of 6 plus with n1. Our n is 6, 6, 1, a to the power of 6 minus 1, b to the power of 1 plus with n2, a to the power of 6 minus 2, b to the power of 2 plus with 6, 3, a to the power of 6 minus 3, b, our b is squared to the power of 3, and let's check. So this is T1, T2, T3, T4. So we should stop here because they asked for the first 4 terms only. Okay, so 2 to the power of 6 is just equals to 64 plus with 6 times with 2 to the power of 5 x squared plus with 15 times with 2 to the power of 4 x Remember, power times with power, we should get x to the power of 4 plus with 20 times with 2 to the power of 3, x to the power of multiply that one, index and index, so x to the power of 6. So 64 plus with 6 times 2 to the power of 5, you should get 192. X squared plus with 15 times with 2 to the power of 4. 240 x to the power of 4 plus with 20 times with 2 to the power of 3, 160 x to the power of 6. So we stop here because we already have 1, 2, 3, 4 terms, and also in ascending power of x. So x starts with x to the power of 2, then start with x to the power of 4, then the next one is x to the power of 6, so it follows in ascending order. Okay, now let's have a look at the next example. Before we start expanding this example, I just want to recall a few things. Remember that square root of x is just equals to x to the power of 1 over 2. And also, if you have a to the power of x times with 1 over a to the power of 5, this is just equals to a to the power of x divided by a to the power of y, which is just equals to a to the power of x minus y. Why? Because a to the power of x is just a to the power of x over 1. And if you multiply ax with 1, you should get ax. 1 with a to the power of y, you should get a to the power of y. And by properties of indices, if you have the same base, you can actually minus the index if it's division. In this case, it's division. So just recall on the properties of indices. Now, let's have a look at this question. Expand these binomial terms. Okay, we know from formula that if we have a plus b to the power of n, and we should know that the first term should be a to the power of n, and then second term should be n1, a to the power of n minus 1, b to the power of 1, plus with n2, a to the power of n minus 2, b to the power of 2, plus with, and the pattern goes on until the last term, which is just b to the power of n. So in this case, our a is 2x, 2 times with square root of x. So we can rewrite this formula into the form of 2x to the power of 1 over 2. Okay. Plus with 1 over x to the power of 1 over 2. Since square root of x is just power of 1 over 2. To the power of 4. So our a is 2x to the power of 1 over 2, and our b is 1 over x to the power of 1 over 2. So we want to expand this. The first term by the formula is just a to the power of n. So our a is 2x to the power of 2 to the power of half. Then to the power of n means that this is to the power of 4. That is our first term. Second term, it should be 4, 1. A is 2x to the power of 2 to the power of n minus 1. So n minus 1. n minus 1, 4 minus 1 is just 3. our b is 1 over x to the power of 1 over 2, okay, to the power of r, which is just 1. In this case, just 1. Okay, so the next pattern, the same. For 2x to the power of 1 over 2 to the power of 4 minus 2 is just 2. B is 1 over x to the power of 1 over 2 to the power of 2. Plus with the third term for 3, a 2x of 1 over 2 to the power of 4 minus 3 is just 1. B is 1 over x to the power of 1 over 2 to the power of 3. Okay. And the last term is 4. How do I know it's the last term? Because we have 4. So obviously, if it's the last term, we just take b to the power of n. So in this case, our b is 1 over x to the power of 1 over 2 to the power of n. Our n for the last term, or n is 4. Okay. And also again, if we have a over b to the power of x, this is just equals to a to the power of x and b to the power of x. Properties of indices again. And if we have a to the power of n x, so this is just equals to a to the power of n multiply with x. So means that we can multiply the index there. These are the basic properties of indices. So that right now, we need to simplify these terms. Okay. So the first terms, it becomes, remember, again, properties of indices. If we have a, b to the power of x, this is just equals to a to the power of x, b to the power of x. So x belongs to both a and b. So in this case, 4 belongs to 2 and also it belongs to the term x to the power of 1 over 2. So it becomes 2 to the power of 4, okay, for the first run. And then x to the power of 1 over 2 to the power of 4. Plus with 41 is 4. Okay. 4 times with 2 to the power of 3, x to the power of 1 over 2 to the power of 3, times with 1 over x to the power of 1 over 2. So because 1 to the power of anything, you'll get 1. Okay. So easily we can see that it becomes 1 over x to the power of 1 over 2 plus with 4c2, it's just 6 times with 2 to the power of 2 and then x to the power of 1 over 2 to the power of 2 and over 1 to the power of 2. It's just 1. Anything to the power of 1 to the power of anything, you'll get 1. And then x to the power of 1 over 2 will need to multiply with 2. Okay. Plus with the third term for C3 is equals to, let me see, 1, 2, 3. So this is done. So we are now at the fourth term. So 4c3 is just equals to 4 times with 2 to the power of 1 times with x to the power of 1 over 2 to the power of 1. So nothing changes there. So 1 to the power of 3. We know that 1 to the power of 3 x to the power of 1 over 2 times with 3. Okay, so anything to the power 1 to the power of anything, you still get 1. And the last term, 1 to the power of 4 over x to the power of 1 over 2 times with 4. And again, any 1 to the power of anything is just equals to 1. Okay. Now, 1 by 1. 2 to the power of 4 is 16. So this one you can multiply. So 4, half times 4 is just equals to 2. Right? So x to the power of 2. Done with the first term. Second term, 4 times 8. Because 2 to the power of 3 is just equals to 8. This is 32. X to the power of 3 over 2 times with 1 over x to the power of 1 over 2. Okay. So done with the next term. Next term. Now 6 times 4, 24. 2 times half. Half times 2 becomes 1. Then you multiply with x 2 times 2 divided 1. 1 over x. Okay, plus with, so we're done with the next term. Next term, 4 times 2 is 8. X to the power of 1 over 2 multiply with 1 over x to the power of 3 over 2. Okay. Plus with, so done with this term. The last term is 1 over x to the power of 4 divided 2. 4, x to the power of 2. Okay. Now, simplify again. 16x squared plus 32. Since x and x, we have the same base just now. If we have a to the power of x times with 1 over a to the power of y, just equals to 1 over x minus y. So this is just equals to 3 over 2 minus 1 over 2 plus with, so done with that term, 24x power of 1 minus, oh, so we can cancel out that one. So it's just 24. This is with 24. So done with that term. Next one is 8. So x to the power of 1 over 2 minus 3 over 2. Okay. So done with that term. The last term is 1 over x squared. Okay. We write back. 32x to the power of 3 over 2 minus 3 over 2. We have 2 over 2, which is just equals to 1. Which is, if it's to the power of 1, we just don't write. Okay, done with that, Then plus with 24, plus with 8, x 1 over 2 minus 3 over 2, we should get minus 1, plus with 1 over x squared. Now, to make this equation, this expansion more beautiful, we can change 8 over x plus 1 over x squared, because x to the power of negative 1 is just equal to 1 over x. X to the power of negative 2 is just equals 1 2 over x to the power of 2. It's just the basic indices. So in this case, I change 8x to the power of negative 1 to 8 over x. So basically, if you can't see, let me do it this way. 1 over x is just x to the power of negative 1 is just 1 over x. So plus 1 over x squared. So rewrite that back. Plus 32x plus 24 plus 8 over x, because 8 is just 8 over 1. So 8 times 1, 8. 1 times x, x. Plus 1 over x squared. That is your final answer. Okay, now let's have a look at one more example. Find the coefficient of x to the power of 5 in the expansion of 3 minus 2x to the power of 6. Okay, to make it short, we do not need to expand everything, but we can actually observe the pattern. We know that the first term, this is your A and this is your B. Okay, so we have A plus B. In this case, our A is equals to 3 and our B is equals to negative 2x. Notice that. Okay, it's negative 2x, not positive. Okay, it's negative 2x. So we know that in any expansion, if we have T1, it's going to be A to the power of n, and B is going to be to the power of 0. So if T1, B is to the power of 0, T2, B is going to be to the power of 2. Since our B is, in this case, our B is, since our B is negative 2x, right? So start with 0. So for the first term, x will be to the power of 0. For the second term, we are going to have B to the power of 1, which is negative 2x to the power of 1. So x going to be to the power of 1. And means that the third term, x going to be to the power of 2. The fourth term, x going to be to the power of 3. The fifth term, x going to be to the power of 4. The sixth term, x going to be to the power of 5. Now we need to look at the 6 terms. And from the one that we learned before, by using this formula, the nth term of a binomial expansion given by this formula here. Okay. So I'll just write down the formula. So this formula is the nth term of a binomial expansion. So in this case, we want to find T6, which is just equals to T5 plus 1, which is just equals to the n is 6, our r is 5, our a is 3 to the power of 6 minus 5, our b is negative 2, x to the power of 5. Okay, so 6c5 is just equals to 6, and 3 to the power of 1 times with negative 2 to the power of 5, x to the power of 5. So 6 times 3 times with negative 2 to the power of 5, we should get negative 576 x to the power of 5. But it asks for, the question asks for coefficient, so coefficient only. So the answer, your final answer should be negative 576, because the question wants us to state only the coefficient of x to the power of. Okay, now let's have a look at one more example. Find the coefficient of x to the power of 3 in the expansion of 1 plus x over 2 multiply with 1 minus 2x to the power of 6. Alright, before we start, let's have a look at the expansion of the second part here, 1 minus 2x to the power of 6. So if you want to expand 1 minus 2x to the power of 6, we know that the first term, we should get a to the power of n, b to the power of 0 from the formula. So in this case, our b is negative 2x. So in terms of x, power of x, will power 0. Means that for term 1, the power of x is equals to 0. And we know that for the second term, b will power is to the power of 1. So it means that t for the second term, x, we will get x to the power of 1. And the third term, we will get x to the power of 2. The fourth term, we'll get x to the power of 3. The fifth term, we will get x to the power of 4. The sixth term, we will get x to the power of 5, and so on. So what I'm doing right now is I'm just looking at the pattern of the power of x. I didn't do the expansion yet. And then, if you look at the question, we have 1 plus x over 2 multiply with 1 minus 2x to the power of 6. So by the normal expansion, we know that we take front, put like that, and we take behind, and we rewrite like that. That is the basic technique of expansion. And if we expand this term, we should get equals to 1 multiply with term number 1 plus with term number 2 plus with term number 3 plus with term number 4 plus with term number 5 plus with da 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 da, similar to the right hand side. So we will times with term number 1 plus term number 2 plus with term number 3 plus with term number 4 plus with term number 5, and so on. The thing is, the question wants us to find term with coefficient of x to the power of 3. So we only need to consider x to the power of 3. And according to the expansion of that, okay, 1 times with what? We will get terms with x to the power of 3. Obviously, term number 4. So other terms we do not need to consider because the question only requires us to find the term with x to the power of 3, coefficient of x to the power of 3. So other terms we do not need to consider. We consider only for the first part here, term number 4. So 1 times term number 4. Why term number 4? Because term number 4 produces x to the power of 3. Okay, how about x over 2? So x over 2 must times with x squared so that we could produce x to the power of 3. So what term will produce x squared? Term number 3. So we do not need to consider other terms, just consider term number 3, the third one. Why am I doing this? Because if you want to expand manually everything, then choose which term suits, it's going to take more time. Now we are doing sort of like a simpler method. So we want to reduce the time taken. So we observe the pattern first. Okay, so 1 times with term number 4. You know, term number 4 from before, we learned that the nth term of a binomial expansion from this formula here. Okay, I'll just bring it forward, okay, and paste it here so we can have a look. So this is the formula of the nth term of the binomial expansion. So we only consider for the third term. So T4 is just equals to, you know that T4 is equals to T3 plus 1. So our R in this case is 3. So we should consider only for the third term. So R is equals to 3. Okay, this is our R. So we should get expansion of 6, right? So 6, 3. A is 1 to the power of 6 minus 3. B is negative 2x to the power of 3. Plus with T3 is just T2 plus 1. So indicates our R is equals to 2. So which means that we have x over 2 multiplied with 6, 2. Our A is 1 to the power of 6 minus 2. Our B is negative 2, x to the power of 2. Okay. Now, we simplify this. So 1 times anything will equals to anything. This one is insignificant. We can just erase that. Still produce the same answer. So 6C3 is equals to 20. Done with that. 1 to the power of anything is just equals to 1. Done with that. So negative 2 to the power of 3. You will get negative 8. Okay, so x to the power of 3 plus with x over 2 multiply with 6c2. So let's do it one by one. 6c2 is 15. Okay, done with that. 1 to the power of anything is 1. And here we should get 4x squared. Okay. So simplify everything. Negative 160 x to the power of 3 plus with so x times with x, we should get x to the power of 3. So now 15 times 4 divided by 2. So negative 160 x to the power of 3 plus with 30 x to the power of 3. So negative 130 x to the power of 3. Since the question want the coefficient, so we do not include the x to the power of 3. So final answer is negative 130. Okay. Okay, the next question would be find the term which is independent of x in the expansion of x squared plus 9 over x to the power of 9. So what does it mean by term independent of x, which means that term with no x. And obviously the option that we have is to expand that binomial and find the term which has no x. But if you want to expand, it's going to take time. So what we can do alternatively is we observe the pattern of x. And we know that by binomial expansion, term number 1 is we always have a to the power of and b to the power of 0. It's always like that. Okay, for term number 1. Term number 2, we will have a to the power of n minus 1, b to the power of 1, and so on. The pattern goes on like that. In this case, just have a look at the pattern of x. So basically, term number 1, we will get a to the power of n, which is 9, b, which is 1 over x to the power of 0. That is for the first term. How about the second term, the third term, the fourth term, the fifth term, the sixth term, the seventh term, the eighth term, and the ninth term? If we look at the pattern, okay, I'll just write it down like that. So obviously this is going to be x squared, 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 x squared. This is 1 over x, 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 1 over x. And obviously for the second term will be 9 minus 1. So it's going to be 9 minus 1. So 9 minus 1 becomes 8. And this is going to get 1. And the third term should be a to the power of n minus 2, b to the power of 2. So this one will be 9 minus 2, which is 7, and 2. If you look at this pattern, it's going down. And here it's going up. So basically from observation, we can see we have 9, 8, 7, 6, 5, 4, 3, 2, 1, and so on. And for the right hand side, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's look at which term that cancel out each other. This one, 9 times 2 is equals to 18. 18 and x doesn't cancel out. 16 and x doesn't cancel out. 14 and x squared doesn't cancel out. So that one, no, no, no. 6 times 2, 12, 12, and x to the power of 3 doesn't cancel out. But we have here. If you look at that one, right. So we have x to the power of 6 multiplied with 1 to the power of 6 over x to the power of 6. And obviously, 1 to the power of 6 is just 6. So this term, right, left-hand side will cancel out with right-hand side. So term number 7 will have x independent. Term number 7, we will have independent of x. Sorry, independent of x. So the final answer is term 7. Okay, so in this case, we do not need to expand everything, find everything, then have a look on the term which is independent of x, but we can just instead observe the pattern and choose the answer. So you should do more practice in order for you to manage to observe the pattern. Now let's have a look at the last example for this topic. Find the first three terms in the ascending power of x in the expansion of 2 plus x to the power of 6. Hence, find the coefficient of x squared in the expansion of 2 plus x minus x squared to the power of 6. If we look at this question, basically it consists of two parts of the question. So we are going to deal with the question part by part. The first part is find the first three terms in the ascending power of x in the expansion of 2 plus x to the power of 6. So we need to find the first three terms. So first part is 2 plus x to the power of 6. Expand that, we should get e to the power of n, which is 2 to the power of 6, plus with nc1 a to the power of n minus 1 is 6 minus 1, 5, x to the power of 1, plus with 6c2, 2 to the power of 6 minus 2 is just 4, x to the power of 2. So we have first term, second term, third term. Enough, because the questioners wants us to find only 3 terms. So the answer should be 64 plus with 192x plus with 240x squared. So you can just use your calculator to find the coefficient of x and x squared. So we've done with the first part. Now we move to the second part. Find the coefficient of x squared in the expansion of 2 plus x minus x squared to the power of 6. So we want to find coefficient of x squared in the expansion of 2 plus x minus x squared to the power of 6. If you notice, if we expand 2 plus something, okay, that's something, 2 plus something to the power of 6, we will get 64, since that something is x. Okay, 64 plus with 192 something plus with 240 something squared. I'm just assuming from here, okay, because 2 plus something is equals to 64 plus 192 something, 2 plus something to the power of 6 plus 240 something squared. It's just basically just substitute. So now if you look at the pattern, that's something in this case, if x becomes x here, if this is y, here becomes y, and here becomes y squared. So in this case, we have 2 plus x. Our x is replaced by x minus x squared. So this is just x minus x squared. So this is x minus x squared and x minus x squared. Okay, let me remove the box there and place it with bracket. Since the question wants us to find the coefficient of x squared, only x squared, so we only need to consider the term with x squared. Basically, we can cancel out 64 because 64 doesn't have x squared. How about the second term here? we only need to consider for 192 multiply with negative x over 2, x to the power of 2, because again we only want coefficient of x squared. So the first term there, we only take that one we don't want, and here also we don't want, since it doesn't produce x squared. So we want the second one, which is basically multiply inside, we will get negative 192 x squared plus with 240, and we know if we expand that, we will get x squared plus blah 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 plus blah 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 blah, whatever behind here will not produce x squared. So we only need to consider for the expansion for the first term only. So in other words, it becomes negative 192 x squared plus 240x squared. The other terms you do not need to consider. If you expand, it doesn't really matter because you will not get x squared. You only will get x squared for the first term of this expansion. So negative 192 plus 240. So you get negative 4, you'll get 48 x squared. So since the question asks you to find the coefficient of x squared, so the final answer should be 48. So that is your first answer. This is that is your second answer. This is your first answer. So this is our last example. More practices you will need in order to master this topic. Try to do all the past years, and if you do lots and lots of practices, you will eventually master this topic. This topic is one of the topics that you can target in your examination paper because it is not that hard. This is just that you need to have a really good eyes and a little bit of, you need to do a little bit of thinking in order to observe the pattern. And I hope that's it. I hope that this video will help you in order to master this question. So in my next video, we will talk about the arithmetic progression and also geometric progression. That's it for now. Thank you very much for listening. Bye-bye. Assalamualaikum.